So in this video, we are going to study about the continuity and one-sided limit. Our standards for the AP calculus are limit 1 and limit 2, in which we are going to study about all the reasons, definitions and the theorems, as well as the properties of the limits. Now, our main success criteria today is to understand how to find out the continuity or discontinuity of a piecewise function and represent it with the help of the graph. So the point is that when do we say that the function is continuous? So understand this fact with the help of a graph. If I am making a graph, if I am drawing a graph without holding my pen out of the board, it means that the line says that the function is continuous because I don't find any kind of gaps or holes in the graph. Similarly, I don't find any kind of broken lines in the graph, and I don't find any kind of vertical asymptotes in the graph. So in these, if I am not getting these three kind of the situations, it means that the graph is continuous. So verbally we can say that the function is continuous if and only if the function is defined at that certain point. Similarly, the limit exists, which means that the right hand side limit is equal to the left hand side limit, and the limit is equal to the function's point. So you can say that the limit exists, function defined, and the function is continuous in that situation. So here, if I want to read any function at point C, I can go up. It is the dark point. It means, and the point, the L, let's suppose the Y value is L. So I can say that f of C equals to L. Similarly, the lines are connecting from each other. So I can say that limit x approaches to C, f of x is also equals to L. Now both the situations are equal, so we can say that the function is continuous. So how many kinds of discontinuities you know? We know there are two kinds of discontinuities, two main kinds of discontinuity. One is removable continuity and the other is non-removable continuity. Now, removable discontinuity, it means that you have in the graph a hole, and this hole can be fulfilled by another point where the function is defined. Non-removable discontinuities are subdivided into three kinds. Number one, the jump discontinuity. Number two, infinite or unbounded behavior. And number three is the oscillating behavior. Now, understand these discontinuities with the help of the graph. Look at the shape of the graph number 1. In the graph number 1, you can see that the lines are broken. So, line coming from the left side towards the A and the line coming from right side towards the A, they are broken. So, in this case, in case of the broken lines, you will say that the name of the discontinuity is called jump discontinuity, and it is the branch of non-removable discontinuity. In graph number 2, you can say that the line coming towards the A from the left hand side is increasing without bound from the left hand side. Similarly, the line coming from the right hand side towards the A is increasing without bound. So the name of the discontinuity is said to be unbounded behavior. So whenever you get a vertical asymptote anywhere, you will define it or you will name it as unbounded behavior. Now in graph number C, you can see that the line coming towards the A from the left side and the line coming from the right side, they are approaching to the same height, but there is a hole in between them. So in case of the hole but connected lines, you can say that the name of the discontinuity is removable discontinuity. Now in graph number 4, again you can say that the line coming towards the A from the left side and from the right side are approaching or are reaching to the same height level. So you can, and there is a hole here again. So you can say that this is also known as removable discontinuity. Now, what is the difference in graph 3 and graph 4? You can see that in graph number 3, the function f of A is not defined. You don't have any shaded point in the graph 3, whereas you have a shaded point M on A. The height is M for the point A. There is a shaded point in the graph 4. But both kinds are same whenever you have a hole with a connected line, whether not you have the shaded point. You can say both of the discontinuities are removable discontinuity. Now look at graph number 5. The graph number 5 is made without holding your hand out of the paper. So you can say that there is no discontinuity in graph number 5, which says that the graph number 5 is continuous. Now, how can we solve the piecewise function? So look at the question. This is the question for the piecewise function. What is piecewise function? Whenever any function consists of two or more equations bound with the different situation, they are said to be piecewise function. Now, in the piecewise function, the most important thing is to analyze the question before solving or discussing the continuity in such kind of questions. Look, this is the condition of the graph. It means the first situation says that the equation minus 2x plus 3 can be used when the function x is less than 1, and the equation x square you can use when the x values are greater than 1 or equal to 1. So now, in order to solve or in order to discuss the continuity, we know that their main point is that we should know that the limit x approaches to some number from the left side. We must read the limit x approaches to some number from the right hand side, and we should know that the limit x approaches to some number from the both sides, and we must know a point f of some number. Now what is that some number? That some number we can take from the situation of the piecewise function, which is describing the whole situation or binding the whole situation at point 1. So the x values which are given at one side of the piecewise function, they are that number, that some number, or they are the conditions of the piecewise function. So you have to read the limit x approaches to 1 from the left side, from the right side, and from both sides. After that from the left side, remember that x, you have a number line here. Let's suppose any number a is written. So you know that this side is the left side. It is the left hand side, whereas this side is the right hand side. Now left hand side can be written as a, and on the top you can write a small negative which shows that this is from the left hand side. And if you write a and on the above or as a bar you can write positive, it means it is showing the right hand side. So left hand side means x is less than a, and right hand side means x is greater than a. And a, the function, that means f of x, you will read when it is x equals to a. Now equal situation can be written with equal sign, can be written with greater and equal, again the equal sign, or can be written as x is less than and equal sign. So again equal, equal, wherever you will see the equal, you will represent, it is enough to represent the f of x. So here the four situations are here you have to fulfill. X from the left hand side, it means you have to read the equation from the left hand side, which means that x should be less than 1. So which equation, if you look at the graph, which equation is representing the function is less than 1? The first equation, you can say that here you have x less than 1. So you write near the limit that equation minus 2x plus 3. Now which equation is representing 1 from the right hand side? It means the x is greater than 1. Here that is your x squared. So write down x squared near the limit. Now limit x approaches to 1 from the both side, you will write f of x because you want to read the whole function. Now equal f of 1, you will read wherever you have the equal sign. So you can see that equation number 2 is representing equal sign. So you write here x square. After that, it is a polynomial function. So just apply the limit. It means replace x by 1. So you will get minus 2 times 1 plus 3. It will gives you plus 1. Now you replace x by 1. That is 1 square, which is equals to 1. Now look, the left hand side and right hand side. Compare the left hand side and right hand side are equal. So you can say that the limit exists at 1. This number, if they are same, you will write 1. If they are not same, you will write limit from the both side does not exist. Now f of 1, just replace 1 over here. So 1 square, which is equals to 1. Now compare the situation. So we have to write in the end that limit x approaches to 1 from the left hand side is equals to the limit x approaches to 1 from the right hand side. And we have to compare that the limit x approaches to 1 from the both side is equals to f of 1. So if both the situations are fulfilled in the question, it means the function is continuous. So your conclusion is that the function is continuous at particular point 1. Now, hope you understood this question. Let's solve one more question. Here the condition of x are given as -2. So the first thing is that you have to write limit x approaches to -2 from the left side, limit x approaches to -2 from the right side, limit x approaches to -2 from both sides, and f of -2. It means you have to collect your all necessary informations. Okay, -2 from the left side means x should be less than. So here is the less than sign. So you will use the equation 3 plus x square. -2 from the right hand side, it means x should be greater than -2. So you will use our third equation, that is 11 minus x square. Now for reading the limit from the both sides, you just write f of x, the name of the function. And f of -2 means wherever you have the equal sign. So here is the equal sign, which is equals to 0. Now apply the limit. Apply the limit. So in place of x, you just replace -2 whole square. That means 4, 5, 6, 7. Here you replace x by -2. So that means 11 minus 4, it will be 7, 8, 9, 10, 11. So both of them are 7. So you can say that the function is equals to 7. Now compare that the limit x approaches to -2 from the left hand side. Yes, it is equals to limit x approaches to -2 from the right hand side. But the second situation which says limit x approaches to -2 from the both side is not equals to f of -2. It is not equal because it is the value of limit is 7 and the value of the function is 0, which means if either of the situation is not equal, you can say that function is discontinuous at -2. So I hope that you understood this question also. Let's solve one more question. Let's solve one more question. So here again collect the data. Limit x approaches to 1 from the left side. Limit x approaches to 1 from the right side. Limit x approaches to 1 from both sides and f of 1. Here left side means the x values should be less than 1. So you will write the first equation because here x is less than 1 representing by the equation -2x plus 3. 1 from the right side, it means x should be greater than 1. So you will write the second equation. Now from the both side, write the name of the function and f of 1 means equal sign. So you can say that the second equation is showing the equal sign. So you write here x squared. Apply the limit. It means wherever you have x, you write down the 1 and calculate. So -2 plus 3 gives you 1. Here you will have 1 squared, that means 1. Now both limit from the left and limit from the right are equals to 1. So limit from the both is equals to 1. And here you will have 1 squared, that means 1. So what have you observed? That the first situation, that limit x approaches to 1 from the left hand side, it is equals to the limit x approaches to 1 from the right hand side. And the second situation or second condition, that is limit x approaches to 1 from the both side, is equal to f of 1. So both the conditions are getting fulfilled. So you can say that the function is continuous at the particular point x equals to 1. Now take one more example. Here discuss the continuity of the function. Again we will write limit x approaches to 3 because 3 is the condition for the x intervals. 3 from the left side. Limit x approaches to 3 from the right side. Limit x approaches to 3 from both sides and limit x and f of 3. Now 3 from the left side means x is less than 3, so which is equals to -3. And now 3 from the right side means x should be greater than 3, which is equals to +3. Limit from the both side we will conclude later on, and f of 3, it means equal sign, which is the second situation, that is -3. Now you don't have the x, it is the constant value, so you will get -3 because there is no place to replace the x by the 3, and here the second limit is the 3 by using the constant property of limit. And if both the limits are not equal, so you will write that the limit x approaches to 3 from both sides does not exist. Now write down the first situation, that means limit x approaches to 3 from the left side is not equals to limit x approaches to 3 from the right hand side. So of course if the first condition is not getting fulfilled, how can the second condition can be fulfilled? But you just write limit x approaches to 3 from both sides is not equals to the function at 3. So what is the conclusion? The conclusion is that the function is discontinuous at 3. So I hope that you understood the concept that how can we find out or discuss the continuity of the piecewise function. In the next video we will see that how can we sketch the graph in order to determine the kind of the discontinuity at the piecewise function.